Hi everyone. So this is our second lecture for the chapter Laws of Motion. So in the previous lecture, we basically discussed the history or the background of these laws of motion, and we started by discussing about Aristotle. That Aristotle simply gave his practical experience, or you can say practical observation, as as a law of motion. What Aristotle said was that an external force is always required to keep the body in uniform motion. This was what he practically observed around him, and this is all. This is actually what everybody observes around him, around him. So, but the problem with this statement was that he did not consider the complete picture. Later on, Galileo, when he conducted his experiments on an inclined plane, he went through certain experiments that we also discussed. The two experiments. The first one was using the inclined plane, simple inclined plane, and the another experiment, it was using the double inclined plane. That when we keep on decreasing the slope of one of the inclined planes in the double inclined plane setup, and we keep on the ball, it again goes to the same height h as was the initial height. So thus, then Galileo said that if some in like if we keep on decreasing the slope, then in the limiting case, that the another portion of the inclined plane will be a horizontal plane, and so the ball should always keep on moving by itself without any external force required. So this were the conclusions of Galileo's experiments. And so what Galileo concluded was that in the case of zero net external force, the body at rest will continue to remain at rest, and the body in uniform motion will continue to move with a uniform velocity. This property of the body was known as inertia. Inertia is nothing but it is a simple term, like which means resistance to change. मीन्स बॉडी जिस भी कंडीशन में है, जिस भी स्टेट में है, वो हमेशा उसी स्टेट में रहने की कोशिश करेगी, वो हमेशा उसी स्टेट में रहना चाहेगी. अगर कोई एक्सटर्नल फोर्स उसे चेंज करने की कोशिश करेगा तो ही वो चेंज होगी. So the result that came out was that Aristotle's laws, they were wrong, and no external force is required to keep the body in uniform motion. But the confusion again here, you need to consider that the Aristotle's laws, they were not completely wrong, because that was the case that he considered when friction was present. That was a practical observations. Galileo's conclusions or the Galileo's results, they simply match with the ideal conditions. So ideal conditions here meaning the absence of any frictional forces or any viscous forces or any other kind of opposing forces. So अगर फ्रिक्शन प्रेजेंट नहीं है या फिर कोई भी अपोजिंग फोर्स प्रेजेंट नहीं है, तो बॉडी अगर यूनिफॉर्म मोशन में है तो इट विल कंटिन्यू टू रिमेन इन दैट यूनिफॉर्म मोशन. उसे मूव करवाने के लिए हमें कोई एक्सटर्नल फोर्स लगाने की ज़रूरत नहीं है आइडियल कंडीशन में. और अगर फ्रिक्शन प्रेजेंट है, जो कि एक्चुअल में होता है, बिकॉज फ्रिक्शन कैन नॉट बी एलिमिनेटेड कम्प्लीटली. हम लोग कोशिश कर सकते हैं कि फ्रिक्शन रिड्यूस हो जाए बाय ऑयलिंग एनी सरफेस, लेकिन और बाय स्मूथनिंग एनी सरफेस, लाइक स्मूथ कर देते हैं जब सरफेस को, बट completely eliminate करना बिल्कुल भी possible नहीं है. That's why in the presence of friction, we also consider that example of a small child playing with a toy car attached to a string which he was pulling. So there we discussed that he is constantly pulling the string. He needs to apply that force basically because the friction is always acting in the direction opposite to the motion of that toy car. So he need to apply another force in the opposite direction to cancel out that frictional force. So now this was all that we discussed or concluded from the previous lecture. Today we are going to see the Newton's first law of motion. So the above Galileo's ideas related to the acceleration or uniform linear motion or zero or the resultant force on a body, they were all taken up by Newton. They were all used by famous Sir Isaac Newton in form of three laws of motion. So the first law of motion that Newton gave, the statement, let me write that statement. So today's first topic would be Newton's first law of motion. The statement of Newton's first law of motion is that everybody must remember every body continues to be in its state of rest or of uniform motion in a straight line unless some external force acts on it to change its motion. So this was the statement given by Newton's first law of motion. Yesterday we also discussed, in the previous lecture, we discussed that the relationship between the net external force and the acceleration of a body. So this first law, Newton's first law, also gives us this relationship. This relationship between what it says is no net external force on the body is related to no acceleration. Here, this double-sided arrow, it simply means that if the given condition is there is zero net external force on a body, then the outcome will be that there is no acceleration. And I mean, the body is either in the state of rest or it is moving in a uniform motion. No acceleration means these two things. These two cases can be no acceleration. Here is, let me write it. The first case is state of rest and the other case is uniform motion. Both these cases ये हमने कल डिस्कस भी किया था previous lecture में. And the second thing that can be derived is if the given condition, if the given condition is zero acceleration, then the outcome will be zero net external force on the body. So both these statements, like both these things, they are included in this in this expression using the double-sided arrow. So here also we discussed that the significance of the word net over here. This net, we discussed that it is basically we are talking about the resultant external force. So that simply means that any body in the state of rest, it does not mean that no force is acting on it. It might be the case. It might be the case that there are many forces which are acting on that body, and all the forces they sum or they sum out to be zero, or their resultant comes out to be zero. So the word net is again the resultant of all the forces acting on that body. So some when we'll solve the practical problems, we'll see that a body is always subjected to the gravitational force whenever the body is there. Like I mean, if that body has mass, then that the force mg will always act downwards on that body. So gravitational force is always there. If that body is in motion, only if that body is in motion, then some opposing forces will also act on that body practically, like we discussed frictional forces and the viscous forces. So at the end of this chapter, we'll also discuss the certain other kinds of forces that are experienced by a body when it is in certain kind of motion. So that will help us in solving the practical problems or the numericals related to this. Now let us consider certain cases so that you are clear with this phenomena. First of all, let's take a book, for example, a book at rest on a table. The book is kept on the table. So initially it may seem that it is kept on the table, it is not moving. That means the force must be zero. But no, it is subject to the two forces. So let me draw this first. If we are talking about a book on the table, this is the surface of that table and the book is kept on that table. So see, what we discussed was every object, if it has mass, it will always have this, it will always experience this force, mg, gravitational force. which is equal to the weight of that object. Now, see, this we know. This the information related to the weight is known to us. And another information known to us is that the object is not moving. The book is stationary, it is not moving. So what we discussed was here that the second information is the body is in the state of rest. I mean this condition. That means there is no acceleration. This is given to us. So the outcome would be no net external force on the body. That simply means that the resultant force on the body would be zero. That means how it can be zero. I mean, if one force is acting on a body, there must be some another force which is acting on that body just equal in magnitude and opposite to that force. See, what we are talking about is there must be some another force which is acting on that body equal in magnitude and opposite in direction. So this force is known as a normal reaction, which generally denoted by the letter N. So, and we can conclude that here N, the magnitude of N will be equal to the weight of that object, which is equal to mg. So this is the outcome. In simpler words, इस कंडीशन में हमें पता है कि देयर इज नो एक्सेलरेशन, बॉडी जो है वो स्टेट ऑफ रेस्ट में है, वो मूव नहीं कर रही है. दैट मीन्स that means no acceleration is present. This is the information known to us. If we know this RHS of this equation, that means the LHS has to be true. इसका मतलब है कि acceleration नहीं है, so the net external force on that body must be zero as per the Newton's first law of motion. This is like this has to be there. So external force zero होना ही चाहिए. लेकिन हमें पता है कि वेट ऑफ द बॉडी दैट इज mg जो है वो वर्टिकली डाउनवर्ड्स एक्ट कर रहा है, ये भी हमें पता है. तो इसका मतलब है कि अगर नेट एक्सटर्नल फोर्स को जीरो होना है, देन एक दूसरा फोर्स जो कि बिल्कुल इक्वल इन मैग्नीट्यूड हो और ऑपोजिट इन डायरेक्शन हो, उसी बॉडी पे लग रहा होना चाहिए, जिसकी वजह से दोनों फोर्सेस एड अप होके या सम होके उनका जो रिजल्टेंट होगा वो जीरो होगा. एंड दैट n or the normal reaction force is equal to W equals to mg. So this was the first example in which we used the Newton's first law of motion. Now let us discuss another example in which we will also be able to understand about the this inertia thing, the concept of inertia, how it is applicable in our daily lives. So for the second case, we'll take a person standing inside a stationary bus. So you must just observe that suppose a person is standing on inside that bus and the driver suddenly starts the bus. So आप लोगों ने भी नोटिस किया होगा कि अगर अचानक से बस चलने लगती है तुरंत और मतलब ज़्यादा एक्सेलरेशन से चलती है, तो आपको पीछे की तरफ झटका लगता है. दैट मीन्स द पर्सन गेट्स थ्रोन बैकवर्ड विद अ जर्क. झटके से आप पीछे की तरफ चले जाते हो. So this instinct also, this law of this concept of inertia is there. So we'll see how. Actually the thing is ki if we look at the ideal condition, I mean the no friction is present. If there is no friction present between your feet and the surface of the bus on which you are standing, that simply means कि if bus move करेगी तो आप move नहीं करोगे. If there is no friction, अगर बस का सरफेस मूव किया तो आप अपनी जगह पे खड़े रहोगे. यू विल बी स्टैंडिंग एट योर ओन पोजिशन एंड द बस सरफेस विल मूव अहेड. इट इज ओनली बिकॉज ऑफ फ्रिक्शन दैट वी आर एबल टू मूव विद द बस. बिकॉज जो फ्रिक्शन होता है वो आपकी फीट को और बस के सरफेस को आपस में अटैच्ड रखता है, एंड बिकॉज ऑफ दैट आप बस के साथ में चल जाते हो, बस के साथ आप भी चल जाते हो. सो otherwise the bus floor would simply slip forward under our feet. So this is also one application of friction that we also discussed in the previous lecture. So now what we are talking about was that when the driver suddenly starts the bus, what happens? What happens? Why we feel that jerk suddenly? So the reason is because see, our body is not rigid; it is deformable. So, when the bus moves forward due to friction, our feet will also move with the surface of the bus in the forward direction. But because our body is deformable, it is not rigid, it is very flexible. Our upper body, the upper portion of our body, will tend to remain at its position due to the law of inertia. लॉ ऑफ इनर्शिया हमने डिस्कस किया था कि इट्स द रेजिस्टेंस टू चेंज, मतलब कि बॉडी जिस भी स्टेट में है वो वैसी ही स्टेट में रहना चाहेगी, चाहे वो रेस्ट हो या वो यूनिफॉर्म मोशन की स्टेट में हो. सो हमारा फीट जैसे ही बस स्टार्ट हुआ, हमारा फीट तो बस के साथ में चल दिया बिकॉज ऑफ फ्रिक्शन, लेकिन जो हमारा अपर बॉडी है वो वो अभी भी स्टेट ऑफ रेस्ट में था पहले. सो वो स्टेट ऑफ रेस्ट में ही रहना चाहेगा बिकॉज ऑफ द लॉ ऑफ इनर्शिया. सो इसलिए वो उस मोशन को रेजिस्ट करता है. ना इमेजिन कि आपकी फीट तो आगे चल गई लेकिन आपका जो अपर पोर्शन है वो पीछे ही रह गया, मतलब वो चला नहीं क्योंकि वो चलना नहीं चाहता है. इसी वजह से आपको पीछे की तरफ झटका लगता है. सो this is the reason we are thrown backward when the driver suddenly starts the bus and we feel that sudden jerk. क्योंकि ये बॉडी कनेक्टेड है एंड देयर आर डिफरेंट काइंड्स ऑफ मस्कुलर फोर्सेस जो सब कुछ बैलेंस करने के बाद इमीडिएटली सब कुछ बैलेंस हो जाता है एंड देन अगेन वी आर एबल टू स्टैंड प्रॉपर्ली. सिमिलरली अब हम व्हेन बस सडनली स्टॉप्स देन वी फील दैट वी आर थ्रोन फॉरवर्ड, लाइक हमें आगे की तरफ झटका लगता है, हम आगे चले जाते हैं. सो अगेन यू कैन अंडरस्टैंड इन दिस वे दैट जब व्हेन द बस सडनली स्टॉप्स our feet is in contact with the bus, so it will also suddenly stop because of friction. But our upper body, that is that doesn't feel friction, no, that is not in contact with that frictional force. So the upper body जो थी वो पहले भी मूव कर रही थी क्योंकि बस मूव कर रही है, upper body भी मूव कर रही है. So because of law of inertia, upper body चाहेगी कि मैं मूव करती रहूं और मैं रुकूं ना. सो जब बस रुक जाती है सडनली तो अपर बॉडी wants to like remains it want to remain मूविंग कंडीशन में रहना चाहते हैं ड्यू टू इनर्शिया. तो वो आगे की तरफ मूव करती है और आपकी फीट पीछे की तरफ रुक जाती है. सो इसी वजह से आप आगे की तरफ आपको झटका लगता है. सो दीज वर द लाइक दिस वाज अ वेरी practical based observation that you must have like everybody must have experienced. सभी लोग ट्रैवल करते हो कार में, बस में, बाइक में, तो ये सबने एक्सपीरियंस किया होगा. बट द ओनली थिंग इज हम लोग कभी ऑब्जर्व नहीं करते चीज़ों को, हम लोग कभी उनके पीछे का रीजन जानना ही नहीं चाहते. वी डोंट वांट टू लाइक नो एनीथिंग, नो द रीजन बिहाइंड एवरीथिंग दैट्स हैपनिंग टू अस. So this was the practical example of inertia. So this is where we'll end the Newton's first law of motion. Now we'll move forward to Newton's second law of motion. So basically, first law like during the first law we saw the cases when net external force is zero. Like this diagram is this expression that is written in front of you. That is for the case when the net external force is zero or the net acceleration is zero, because both imply the other one. So the but here the second law of motion, it considers the situations when the net external force is not zero, and it also tells about like how are the force and acceleration related in this case. So it's simple. Let's first move on to momentum. So what we are discussing is Newton's second law of motion, and in that we'll first discuss this concept of momentum. What is momentum? Momentum is defined as the product of mass of the body and its velocity v, and we denote momentum by the letter p. So small p is always known to be momentum in case of physics, and capital P we generally say that it's pressure. So don't get confused. We are talking about motion. So here it will be momentum only. This is the product of mass and the velocity. Now this expression you can see that because velocity is a vector quantity and we had studied in the lectures of the motion on a plane that when a vector quantity is multiplied by a scalar quantity, mass is the scalar quantity. So when the vector quantity is multiplied by a scalar mass, it will it will result in a vector quantity only. So that's why momentum is also a vector. Now coming to why are we going to study momentum before getting to the Newton's second law of motion is see, this expression contains two quantities, that is m and v. So why is the reason are we relating these two quantities or are we combining these two quantities to get momentum? So basically first we'll see the effect of mass m of the body on the motion of a body. So you must have observed that a much larger force is needed to shift a bed from its position as compared to move a chair. Like अगर आपको बेड एक जगह से दूसरी जगह पे खिसकाना है तो आपको बहुत ज़्यादा फोर्स लगाना पड़ेगा और अगर वहीं एक हल्की सी चेयर रखी हुई है अगर उसको आपको शिफ्ट करना है तो आपको ज़्यादा फोर्स लगाने की ज़रूरत नहीं है. So or similarly, larger force is needed to stop a heavy body than to stop a light body in motion. अब इमेजिन करो कि कोई एक कोई बड़ा आदमी भागते हुए आपकी तरफ आ रहा है, like he is in motion and he is coming to you, so you will need a larger force to stop him. And if वहीं पे दूसरी जगह पे कोई एक छोटा बच्चा भागते हुए आपकी तरफ आ रहा है and you need to stop that small child, then you'll need a lesser force. So this simply means that mass is an important parameter that has an effect on the force which has to be applied on a body to change its state of motion. So इसका मतलब है कि that's why mass is important. So the second parameter here included is velocity. So if we talk about the practically, you must have observed that a larger force is needed to stop a moving body with high speed as compared to a body which is moving slowly. So if for example we say even if him matlab if we in this case if we consider mass of the body as a constant. So if we consider again this example of a small child, so the child is same, that is the mass of that child is considered to be same abhi, but his velocity is different. Like in first case he is coming with a very high velocity, बहुत तेजी से भाग के आ रहा है आपकी तरफ, and in the second case he is coming slowly towards you, like his velocity is not very large, he's just running normally. So you will see that a larger force is needed to if larger force is needed to stop him if if his velocity is more. So that means in some or the other way, if mass is kept constant also, then velocity also plays some kind of role in the changing the motion of a body. Therefore, this parameter velocity is also important. Therefore, as bodies quantities, they are very important in this case in mass and velocity. So they are product of mass and velocity, which is known as the momentum. It has to be considered to study the force on a body. That's why we are going to relate everything with momentum now. So it has to be a very important quantity that we'll see in the later chapters also. That is very important. So if we want to study the state, like if we want to write a statement, a concluding statement relating momentum to force, then we can say the greater the change in momentum of a body in a given time, the greater is the force that needs to be applied on that body. So in simple terms, if we say that if a body, like if a body's velocity is changing or the body's mass is changing, which is generally not the case, but if we consider this product mv, if this product mv of a body is changing, like its state of motion is changing, then जितना ज़्यादा mv में चेंज होगा, जितना ज़्यादा मोमेंटम में चेंज होगा, उतना ही ज़्यादा फोर्स हमें लगाना पड़ेगा टू चेंज दैट मोशन, change the state of motion of that body. तो अगर कोई बॉडी रुकी है, लाइक अगर कोई बॉडी स्टेट ऑफ रेस्ट में है और हम चाहते हैं उसे मूव कराएं, तो उसे मूव कराने के लिए जितना ज़्यादा मोमेंटम में हमें चेंज करवाना पड़ेगा, उतना ज़्यादा हमें फोर्स भी लगाना पड़ेगा। दैट मीन्स इफ वी वांट कि दैट बॉडी स्टार्ट्स मूविंग विद अ वेरी हाई वेलोसिटी, तो हमें फोर्स भी ज़्यादा लगाना पड़ेगा। ऑन द अदर हैंड, इफ वी टॉक अबाउट द मास, इफ द मास ऑफ दैट बॉडी इज मोर, तो भी हमें ज़्यादा फोर्स लगाना पड़ेगा। So this product MV is really very important. Now we'll also consider here some other factors that are very important for the for studying the motion of the particle or a motion of an object. This was about momentum, like how why we study momentum. So then we also come to one another factor, which is time. See, this is a very confusing thing because most of the students, they don't understand this concept properly. It's not difficult at all. It's only just if you are able, if you try to understand it using the practical experiences or practical observations, then it becomes easy. So here also we'll first start with an example. Like suppose if a ball is coming towards you and you need to catch it. So if you try to catch the ball instantly, मतलब आप तुरंत ही बॉल को तुरंत बिल्कुल डेल्टा टी टेंडिंग टू 0 पे आप उसे कैच करना चाहते हो और अपने हाथ एक जगह पे फिक्स रखते हो एंड देन यू ट्राई टू कैच द बॉल, यू माइट हर्ट योर हैंड बिकॉज उस टाइम पे फोर्स बहुत ज़्यादा होता है। अभी वील सी दिस कॉन्सेप्ट। एंड ऑन द अदर हैंड यू मस्ट हैव सीन द क्रिकेटर्स, लाइक आप लोग मैच तो देखते ही होंगे, क्रिकेट मैच। So you must have seen cricketers, like when they are catching the ball, they allow a longer time for their hands to stop the ball, and that's why they are not like they don't hurt themselves, and they don't have to apply much force also. So like the cricketer, like when he is getting a ball towards him, he will not keep his hands fixed. Like if you keep your hands fixed, then the ball will directly impact to your hands and you may get hurt because the more force is required to stop that ball and your hand is applying that force, so it may get hurt. But what cricketers do is that they do not keep their hands fixed like this. If I explain this to you with the help of a figure, like like see, if a ball is coming from here, see first, like this is the hand, suppose. Sorry for my drawing, but I mean you'll be able to understand properly. If ball is coming and if you keep your hand fixed matlab at this position only, then we abhi discussed that it may hurt your hand because the force by that ball is very high because acceleration is there, no? That's why. What the cricketers do on the contrary is they don't fix their hand to a particular position. As if the ball is coming towards them, the ball, they also move their hand with the ball. I mean, first their hand is like this, then their hand would be something like this, then their hand might और नीचे चला जाएगा, somewhat like this. So when the ball is coming towards, like when the ball is landing on the hand, then they keep on moving their hand downwards. You must have observed this in the cricket matches and all. So this is the reason because they give more time to the ball to like to bring its velocity to 0. That's why they don't get hurt and they do not have to apply a larger force. So this is where time, like delta t time interval that is given for that change of momentum. That is important here. So if the statement, if we want to conclude this, we can say here the word rate is very important because we are talking about time interval, that's delta t. So the word rate, it always means that if like if we are talking about the rate of some quantity, then that will mean that quantity divided by time. So if we like, this is not any expression, but that it's just a way to define things. Rate can be considered as quantity by time. So if here we are talking about the rate of change of momentum. So basically we are talking about the change of momentum in some particular time delta t, time interval delta t. So it says that greater the rate of change of momentum, the force required is more. Now we're also going to study the same effect of momentum which is related to the different bodies which we just previously discussed, but this is when we are talking about the momentum as a whole. Abhi we discussed taking mass as a separate quantity, taking velocity as a separate quantity, then taking time interval as a separate quantity. So that was these were the individual quantities. And now here if we talk about momentum as a whole, so this momentum is m into v. So what we do is suppose a fixed force F is applied for a certain interval of time delta t. That means here F is a constant. F has been fixed. It's not a constant. I mean it has been fixed, and delta t has been fixed. So when that fixed force F is applied on the two bodies of different masses, both are initially at rest. Lighter body, it reaches to the more speed than the heavier body. That means what we have said Abhi is that F is fixed, delta t is fixed, the time interval is also fixed, and two bodies are there, both are initially in the state of rest. So suppose they are of different masses, so this is body of mass m1 and this is another body of mass m2. So if these two bodies are there, they are initially in the state of rest, and we apply force F for a time interval delta t on both these bodies, then we will see that the lighter body will reach the higher speed. Let's suppose delta t is a constant, so suppose after 5 seconds we are applying a force F for 5 seconds in both the bodies, so we will see that the final velocity of this body is v1 and the final velocity of this body will be v2 because their masses are different. So what we will say is that the lighter body will reach the more speed because if m1 is less than m2, then v1 will be more than v2 and vice versa. ये तो बहुत ऑब्वियस सी चीज है जो हम लोग प्रैक्टिकली ऑब्जर्व करते हैं कि इफ मान लो कोई छोटी सी बॉल है एम वन मान लो कोई छोटी सी बॉल है 10 ग्राम की बॉल ले लिया आपने और उसी जगह पे हमने एम टू ले लिया बहुत बड़ी भारी सी आयरन की बॉल ले लिया जिसका मास बहुत ज्यादा है सपोज करो 10 kgs है ठीक है तो आपने एक 10 ग्राम की बॉल ली है ये 10 ग्राम की बॉल ली है और यहीं पे आपने 10 kg की बॉल ले ली है और अगर आप सेम फोर्स लगाते हो इन दोनों बॉल पे फॉर सेम इंटरवल फॉर 5 सेकेंड सपोज देन जब हम फाइनल वेलोसिटी मेजर करेंगे तो वी विल ऑब्जर्व दैट द फाइनल दैट इसकी जो वेलोसिटी होगी वो बहुत ज़्यादा होगी क्योंकि ये छोटी सी बॉल है ना तो हम उतने ही फोर्स में ये ज़्यादा तेज़ी से भाग जाएगी और जो दूसरी वाली बॉल है जो कि भारी है तो हमें उसमें हम लोग फोर्स उतना ही लगा रहे हैं क्योंकि फोर्स उतना ही लगाएंगे तो इसकी वेलोसिटी कम रहेगी तो इसी वजह से v2 की वैल्यू इज लेस देन v1. So if we conclude this statement again, then we can say that it is observed that both the bodies acquired the same momentum. ठीक है इन दोनों के मास अलग थे इनका वेलोसिटी भी अलग आया लेकिन जब हम लोग एक्सपेरिमेंट्स के थ्रू या फिर कैलकुलेशंस के थ्रू ये चीज़ देखते हैं तो इट इज ऑब्जर्व दैट जो मोमेंटम है भले ही दोनों का मास और वेलोसिटी अलग अलग डिफरेंट हो बट उनका जो मोमेंटम निकल के आता है दोनों का सेम निकल के आता है. So this is the conclusion I was talking about. इसी वजह से मोमेंटम और फोर्स बहुत ज़्यादा मतलब मोमेंटम इज अ वेरी इंपॉर्टेंट क्वांटिटी टू इन रिलेशन विद द फोर्स. So if you want to conclude this, so let me write the concluding statement. The same force for the same time causes the same change in momentum for the different bodies. That means अगर मैथमेटिकली इसको लिखें तो मान लो m1 जो m1 क्योंकि दो डिफरेंट बॉडीज है तो एक का मास m1 है और एक का मास m2 है। m1 वाली बॉडी जो है मान लो उसकी फाइनल वेलोसिटी इज v1, m2 वाली की जो फाइनल वेलोसिटी होगी वो v2 होगी। तो ये तो अलग अलग आ जाएगा। इनके बीच में रिलेशन क्या होगा? द रिलेशन हियर इज गिवन बाय दिस स्टेटमेंट। दैट मीन्स m1 v1 is equal to m2 v2. So तो m1 v1 is equal to m2 v2। तो जो चेंज इन वेलोसिटी आएगा ना वो इन दोनों चेंज इन मास जो रेशियो ऑफ मास पे ही डिपेंड करेगा। द रेशियो ऑफ द वेलोसिटीज विल डिपेंड अपॉन द रेशियो ऑफ masses of these bodies. Now we have been talking about the momentum because so as we discussed that momentum is a vector quantity, so there must be some direction of momentum also, and we also must be aware of that direction. So let me first we say that the direction of momentum will be the direction of velocity itself. So suppose in the uniform circular motion that we discussed that when a stone is rotated with with some uniform speed in a horizontal plane by means of a string, then we know that its velocity will change. We had discussed that its acceleration and velocity both change at every instant. So the change in the velocity will also cause the change in the direction of momentum, because in uniform circular motion we discussed that the magnitude of velocity will be same because it is uniform, but the direction of velocity will change, and that is why the direction of momentum will also change. So अगर आप डायरेक्शन के बारे में बात करें तो if you consider that if this is your hand and you are just holding a string and you are just rotating that this is and you are rotating this stone. We are rotating the string which is attached to the stone in a horizontal circle. So उसका जो velocity होगा we discussed that was if this is the stone, so its velocity will be in the direction of tangential direction में. Similarly हम देखेंगे तो जो हमारा मोमेंटम का डायरेक्शन होगा वो भी सेम डायरेक्शन में ही होगा. So the momentum will change, the direction of momentum will change at every instant. So इसमें भी we must like by experience we can say that our hand needs to exert a greater force if the stone is rotated at greater speed or in a circle of smaller radius. तो अगर हम ज़्यादा स्पीड से स्टोन को घुमाना चाहते हैं, सर्कल में घुमा रहे हैं हम स्टोन को, तो ज़्यादा स्पीड से घुमाना चाहते हैं तो भी हमें ज़्यादा फोर्स लगाना पड़ेगा अपने हाथ से। और अगर हम स्मॉलर रेडियस के सर्कल में घुमाना चाहते हैं तो भी हमें ज़्यादा फोर्स लगाना पड़ेगा। तो आप लोग भी अपने घर पे एक ये एक्सपेरिमेंट छोटा सा कर सकते हैं कि जस्ट टेक अ स्ट्रिंग tied with a tie that string with a stone to a stone and then you start rotating this. तो अगर आप छोटी स्ट्रिंग लेंगे, छोटा छोटा स्ट्रिंग लेंगे तो उसका जो जो सर्कल बनेगा दैट विल बी अ स्मॉलर रेडियस सर्कल, उसके लिए आपको ज़्यादा फोर्स लगाना पड़ेगा। ऑन दी अदर हैंड अगर आप लंबा स्ट्रिंग लेते हैं और फिर हम घुमाते हैं स्टोन को तो हमें उतना फोर्स नहीं लगाना पड़ेगा घुमाने में। So this you can also try it yourselves at home. It's a very normal thing. So that means the greater the rate of change in the momentum vector required, the greater is the force applied. So what we discussed, like all the factors, all the quantities that basically affect the force applied on that body or affect the change in the motion of that body, like mass हो गया, velocity, momentum as a whole, that's the product of mass and velocity, then time interval, that's delta t. So all these quantities. So Newton expressed the second law of motion using all these observations that we discussed. We had discussed several practical applications or there are several practical examples today. जो हम बहुत डेली बेसिस पे ऑब्जर्व करते हैं, बट वी नेवर एवर थिंक अबाउट दैट कि उनके पीछे का रीजन क्या है, व्हाई अ थिंग इज हैपनिंग और व्हाई अ थिंग इज नॉट हैपनिंग. We just don't question. So Newton used all these above observations and he expressed the second law of motion. So now we're going to write the second law of motion. This statement is what Newton gave, that the rate of change of momentum, the rate we discussed is the change of momentum divided by time interval. That is the rate that we are including the factor of time, time, like delta t also in this statement. So this was a statement which was given by Newton as in the form of second law of motion. So it says that the rate of change of momentum of a body is directly proportional to the applied force and is in the direction of applied force. So see, in this statement, all the things are included, that whatever we discussed in today's lecture, like all the factors that we discussed. See, like we discussed about mass, so that mass is included in this momentum thing because that's mv. Then the factor of velocity is also included in the momentum, and we also on combining mass and velocity, we also discussed the effect of momentum. Then we came to the time interval, that was delta t, that taking that example of a ball which is coming, and where as you try to stop a ball or some another cricketer, experienced cricketer would try to stop a ball, so that's different. And the cricketer will need to apply lesser force, so that was the effect of delta t. So here in the word rate, that the effect of delta t is included, and mv in the word momentum is included, is directly proportional to the applied force, because applied force, it depends upon all these three factors. So we have all combined these, and this change of momentum is in the direction of the applied force. So that's pretty normal, that जिस भी direction में हम force लगा रहे हैं, जिस भी direction में, उसी direction में हमें change मिलेगा. velocity में change आएगा, velocity में change आएगा तो momentum में आएगा. So like you can also understand this way, that when you are that string, that stone tied with a string, if you do an experiment at your home yourself, you will see that you need to rotate your hand, no, in all day, in like in a circular way also. For rotating the string, आपको अपना हाथ भी घुमाना पड़ेगा. आप कैसे घुमाओगे स्ट्रिंग को? So that is this direction of applied force, कि आप जिस डायरेक्शन में आप स्टोन को घुमाना चाहते हो, उसी डायरेक्शन में आपको अपना हाथ भी घुमाना पड़ेगा. So this direction is also the same. So now we have discussed the Newton's second law of motion completely. This was today what we discussed was basically the theoretical or the basics, which are theoretical knowledge or theoretical concepts, you can say, related to this thing. In the next lecture, what we'll do is we'll carry on with the mathematical derivation, because the first law of motion was completely theoretical. I mean, there was no mathematics involved with that. But in the second law of motion, there is also a mathematical derivation. We'll see that it leads to some expression, and that expression is very useful. Like it's applicable almost everywhere. So in the next lecture, we will look up to that mathematical derivation and that final result that is known as the result of second law of motion. This was all for today. Thank you.